In this lesson, we're going to continue with the chapter on qualitative analysis. We have already looked at the different tests for cations in the last lesson. In this lesson, we're going to focus on the test for anions. Now, the test for anions is going to be slightly more complicated than cations. Why is that so? Because for all the 8 cations that is in syllabus, we add the same reagents to them. We either add sodium hydroxide or aqueous ammonia. But for anions, each anion will require a different set of reagents added. So you need to memorize for each particular anion what are the reagents to be added. So there are 5 anions that we need to learn in the syllabus, and they are carbonate, chloride, iodide, nitrate, and sulfate. So as mentioned, the reagents that we need to add for each anion, they are different. So we're going to look at them in detail in the next few slides. So this is an overview of the different reagents that we need to add for each anion and the expected observations. Don't worry, we are going to go through each anion one at a time. The first anion that we'll look at is the carbonate anion. To test for carbonate, we need to add any dilute acid. Okay, and the observations that we will see if carbonate is present will be effervescence. What is effervescence? Effervescence simply means bubbles. Okay, why is that so? It's because we have learned in acids and bases that acids will react with carbonates to produce carbon dioxide gas. Whenever a gas is being produced, we will see bubbles, we will see effervescence. Now, how do we further confirm that it's a carbonate? Is to test for the gas, and if it's a carbon dioxide gas, we can be sure that the anion that's present is carbonate. So how do we test for carbon dioxide gas? We have to bubble the gas into a solution of lime water. And if the gas is carbon dioxide, we'll again see this in the test for gases. The lime water will form, there will be a white precipitate that will be formed in the lime water. In traditional textbooks, you will see this phrase that lime water turns chalky, lime water turns murky. Indeed, that's the observation, but the more correct way of stating will be that a white precipitate is formed in lime water. The next anion that we'll look at is nitrate. To test for nitrate, we need to add sodium hydroxide, and then we need to add a piece of aluminum foil, and then followed by warming. And if nitrate is present, we will produce ammonia gas. And how do we test for ammonia gas? Is by using a piece of moist red litmus paper. So imagine we have a solution containing nitrate. I will add sodium hydroxide in there, and then I'll put a piece of aluminum foil, and then I will warm it. Okay, after some time, you should smell a very pungent gas that's being produced, and then when you test with a piece of red litmus paper, you will find that the red litmus paper turns blue. That confirms that ammonia gas is present, ammonia gas is produced, and the ion that's present, the anion that's present in solution is nitrate. Now this test is very similar to the test for ammonium ions, ammonium cations, but the difference here is that to test for nitrate, we need to add one additional reagent, which is aluminum foil. Now for those of you who are curious, so why would adding aluminum foil and sodium hydroxide produce ammonia gas? Because I don't see any ammonium in nitrate. Is this that nitrate will react with aluminium, alright, in a type of reaction called a redox reaction to produce ammonium ions. And then what happens when you have ammonium ions in the presence of hydroxide is that you will produce ammonia gas. So this is actually what is happening. The aluminium foil is reacting with nitrate in a redox reaction to produce ammonium ions, which will then react with hydroxide to produce ammonia gas. So this is the theoretical basis for the test of nitrates. The next anion is sulfate. So the reagents that we need to add is this. We need to add dilute nitric acid followed by barium nitrate. And if sulfate is present, we will see a white precipitate. Now the identity of the white precipitate is actually barium sulfate. We have learned in the topic of salts that all sulfates are soluble except for calcium, barium, lead. So in this case, we can test for sulfate by adding barium nitrate. And if sulfate is present, we will see a white precipitate being formed. Now a very common question that we will get is why is there a need to add nitric acid? Now to answer that, let us imagine the scenario that I have a solution that contains an unknown anion. Alright, so I am going to add barium nitrate to the solution without nitric acid, so only barium nitrate. And the observations are as follows. I see a white precipitate being formed. Now based on the observations, can I conclude that the unknown anion is sulfate? Now the answer is no. Why is that so? Because barium can also, besides forming a white precipitate with sulfate, barium can also form a white precipitate with carbonate, and in high enough concentrations it can also form a white precipitate with hydroxide. Okay, so when we see a white precipitate form when we add barium nitrate to a solution, the anion present could be sulfate, carbonate, or hydroxide. So we cannot conclude. But if we were to add dilute nitric acid first and a white precipitate is formed, we can be sure that it's sulfate. Why? Because if carbonate is present, right, it would have reacted with your nitric acid. Remember, all carbonates will react with acid. If hydroxide ions are present, it would have been reacted with your nitric acid as well. So if we had added nitric acid in the first place, that would effectively remove any carbonate or hydroxides that may be present, and then followed by barium nitrate, and a white precipitate is formed, we can be sure that the anion that is forming the white precipitate is sulfate. So essentially the purpose of adding nitric acid is this, is to eliminate any other ions that will give a white precipitate with barium, so that we can conclude that the anion present is sulfate should a white precipitate be formed. Now in the test for chloride and iodide, the reagents that we add are the same. We add dilute nitric acid followed by silver nitrate. The observations will be slightly different. For chloride, you will see a white precipitate. For iodide, you will see a yellow precipitate. Okay, by now you should be able to deduce that the white precipitate is actually silver chloride. Okay, because we are adding silver nitrate, so it has silver ions. Alright, and the yellow precipitate is silver iodide. Now, the same thing, we see that prior to adding the reagent silver nitrate, we have to add dilute nitric acid. Now, what is the purpose of that? Again, it's because silver ions can not just form a precipitate with chloride and iodide, it can also form a precipitate with carbonate and hydroxide. So the purpose of adding nitric acid is to ensure that when a precipitate is seen, that is due to either chloride and iodide and not carbonate and hydroxide, because nitric acid can react with carbonates, it can react with hydroxides. So it will eliminate any other ions that can give a precipitate with silver ions. Now that we have looked at the test for the different anions as well as the expected observations, let us try a few questions. In this question, it's describing the test for an anion where we add an acid followed by test of the gas with lime water. So this is a classic test for carbonate. For this question, aqueous silver nitrate is added to potassium chloride and sodium iodide. So we have seen that silver nitrate is to test for your chloride and iodide, and if chloride is present, we will see a white precipitate. If iodide is present, we will see a yellow precipitate. In this question, we are given a flow chart. The flow chart describes a series of tests on a compound Y. In the first test, nitric acid was added, which produced a gas. So we need to recall in the test for cations and anions, which one do we add an acid, and the expected observation is a gas being formed, and that would be the test for carbonates, and the gas is carbon dioxide. So what this means is that compound Y is likely to contain the anion carbonate. Next, we get a colorless solution, and then we added sodium hydroxide, and we saw a white precipitate insoluble in excess. So we have to, from the reagents added, we must be able to know that in this step we are testing for the cations that are present, and the cation that will give a white precipitate insoluble in excess, sodium hydroxide, would be your calcium ions. So that also means that your compound Y must contain calcium ions. So the compound Y would be calcium carbonate. In this question, we are given the scenario where a student makes two solutions Y and Z, which results in the formation of a white precipitate. So they are asking which one could not be Y and Z. So let's analyze the different options. In option A, we are mixing silver nitrate and hydrochloric acid. So that's the test for chloride, and we know that a white PPT will be formed. In option B, we are adding sodium nitrate to hydrochloric acid. In this case, the salt that's formed is actually sodium chloride, so you will not see any PPT. In option C, we are adding sodium chloride to lead 2 nitrate. So if we analyze the salts that can be formed, how do we analyze? Is by swapping the partners. We swap the anions and the cations for the two solutions. So a possible salt that we can get is lead 2 chloride. Now, is lead 2 chloride soluble? We have to go back to our solubility rules. All chlorides are soluble except silver and lead. So in fact, lead 2 chloride is also a white precipitate. And lastly, sodium chloride with silver nitrate. We have chloride and silver, so that will give us silver chloride, which is a white precipitate. So only in option B, where we do not have any precipitate form. In this question, again, we are given a salt Q. Alright, we are told that it's a soluble salt, and then there were two tests that were being performed. One is to warm Q with sodium hydroxide, and then you get an alkaline gas given off. So we need to go back to our test for cations and anions. When do we warm a solution with sodium hydroxide, which will produce an alkaline gas? That is the test for ammonium ions, and the gas produced is ammonia gas. So next, the next test is by adding dilute nitric acid followed by barium nitrate. So again, which test, the test for which anion do we add barium nitrate? The answer is sulfate. And the fact that a white precipitate is formed tells us that sulfate is present. So from the observations of the different tests, we can conclude that Q contains ammonium ions, it contains sulfate ions, so it must be ammonium sulfate. Let's look at one last example. So we have a solution of compound X, and then it's reacted with sodium hydroxide to form a green precipitate. So that tells you that iron 2 ions are present. And then aluminium powder is added. So aluminium combined with sodium hydroxide. If you can recall, that is the test for nitrate. When the mixture is heated, a gas that turns damp red litmus paper blue is given off. So that tells you for sure that a nitrate is present. So X contains iron 2 ions and nitrate ions. The X would be iron 2 nitrate.